It was American economist Milton Friedman who said, "Never try to walk across a river just because it has an average depth of 4 feet." In this lesson, we're going to explain how data is smoothed. We're going to calculate simple moving averages using an arithmetic average formula, and we're going to calculate simple moving averages using the subtraction and addition method, as well as graph simple moving averages using a spreadsheet. All to answer the question, how can historical stock market data inform future trends? Before we get into it, let's make sure we're ready for it by looking at warm-up number 2. Given that A is greater than B, greater than C, greater than D, which of the following has the greatest value, and explain your reasoning. A being the average of all of them means we're going to do A plus B plus C plus D and divide that by 4. Now the sum of A, B, C, and D is, of course, A plus B plus C plus D. Now, when we look at A, the most this can be if all of them were equal, which we know they're not because it shows a greater than, D would be the greatest value. But since we're lowering it by dividing it by 4, we know that B is going to be greater than A, so A can't be an answer. The difference between D and A means D minus A. This is going to give us a number lower than D, and the sum of all of them will give us a number greater than D. Now, let's take a look at a problem that you will be able to do by the end of this lesson. Examine the 36 consecutive trading day closing prices for ZZB. The chart covers the trading days from January 6 to February 26. Construct a scatter plot and find the regression lines and the correlation coefficient. Use the equations to predict the closing price on the 37th day of ZZB. Using a graphing calculator, graphing software, or online graphing website, or even a spreadsheet, you can generate the following scatter plot, starting with January 6 as the day 1 and January 7 as day 2, and so on. Use the ordered pair 1, 34, 2, 33.51, etc. in that form. Day number, closing price to construct a scatter plot. The regression line is determined using the ordered pair in the chart. This line has a positive slope, indicating an increasing price trend. The correlation coefficient is strong at 0.94. Use the linear regression equation to make a prediction for the closing price on the 37th day. We're going to substitute x is equal to 37 into the equation. Y is equal to 0.1123x plus 33.583 and round to the nearest penny. So we just simply get to say that equation. Y is equal to 0.1123 times 37 plus 33.583. And this is going to give us that y is equal to 37.74. The predicted closing price for the 37th trading day is $37.74. Stock market prices can fluctuate greatly from trade to trade based on a variety of external factors. You have already seen that the high and low for a day may not necessarily be near the day's opening or closing prices. Those differences often make it difficult to spot trends over time. In this lesson, we're going to learn 2 techniques that will give you insight into analyzing historical stock market closing prices. The first technique will answer the question, how can stock data be smoothed? The second will answer the question, how do peaks and valleys in closing prices assist in making buying and selling predictions? Statistical tools that allow an investor to reduce the impact of price fluctuations and to focus on patterns and trends are referred to as smoothing techniques. One such technique is known as a simple moving average, or SMA. Simple moving averages are calculated by determining the mean, the arithmetic average, closing price over a given period of time. The graph shows the daily stock closing price, a 5-day SMA and 10-day SMA over a period of 30 trading days. Notice how the closing prices fluctuated from day to day and the moving average graph smoothed the data. The longer the moving average time interval, the smoother the graph appears to be. Moving averages are known as lagging indicators because they use past data. Investors use simple moving averages when they want to identify the following trends in prices. Recall that the mean or arithmetic average of a set of numerical data is the sum of the items in that set divided by the number of items. You can determine the average of any number of closing prices, but this gives you little information about trends because you would have nothing to compare the average to. A better comparison method to use is the simple moving average. Now let's explain how the data is smoothed. Simple moving averages use arithmetic average formula. Although simple moving averages can span any length of time, in our first example, we're going to find the averages by taking the closing prices 5 days at a time. Days 1 through 5, days 2 through 6, 3 through 7, 4 through 8, 5 through 9, and 6 through 10. These are known as the 5-day simple moving average, or the 5-day SMA. You will then graph the 6 averages. The graph will have a smoother appearance compared to the graph of the closing prices of day 5 through 10. A moving average graph smooths the fluctuations in closing prices to make trends easier to see. Objective. Now let's calculate simple moving averages using an arithmetic average formula. The closing prices for 10 consecutive trading days for a particular stock are shown. Calculate the 5-day SMA and plot both the closing prices and the averages on a graph. Now we're going to find the average of the closing prices in groups of 5, meaning day 1 through 5 to begin with. This means we're going to take 3502 plus 3501 plus 3465 plus 3609 plus 3532. The sum of that divided by 5 is going to give me approximately $35.22. Now, if I do the same thing when it comes to 2 through 6, now we're going to drop off the first price but add in a new price. This is going to give us 35.31. 3 through 7 is going to give us 35.32. 4 through 8 will give us 35.55. 5 through 9 will give us 35.74. And 6 through 10 will give us 35.89. The 5 consecutive 5-day SMAs are 35.22, 35.31, 35.32, 35.55, 35.74, and 35.89. The graph of the closing prices and the simple moving averages for days 5 through 10 are shown. Notice how the moving averages smooth out the graph. Let's check our understanding. Closing prices for 10 consecutive trading days were $55, $60, $62, $48, $40, $42, $45, $46, $43, and $49. Calculate the 5-day SMA, plot the closing prices and the average prices on the graph. The first thing I do is I plot those 10 points on the graph as they are, the actual closing prices. Then we go find the SMA for days 1 through 5, and this will be plotted on day 5. This is going to give us 53. So on day 5, we found an average of 53. On day 2 through 6, we get 50.4. So 50.4. For days 3 through 7, we get 47.4. We put that 47.4 onto the graph. And for days 4 through 8, we find 44.2. Putting 44.2 on the graph. For days 5 through 9, we get an average of 43.2. We hit our crossover point. And for days 6 through 10, we get an average of 45. So now when we connect these, we get a nice smoother line. The calculation of a simple moving average can be tedious because you have to find the average for each time interval. There is an alternative way to compute the moving average that is simpler. Suppose you want to determine a 3-day simple moving average for 6 trading days. Let the trading prices for the days be represented by A, B, C, D, E, and F. The trading prices for the first 3 days are A, B, and C. The average of those prices is the sum of A, B, and C divided by 3, which is also A divided by 3 plus B divided by 3 plus C divided by 3. Using the method in example 1, we can find the average for days 2 through 4 using B, C, and D. This is the same as subtracting price A and adding price D, or A over 3 plus B over 3 plus C over 3 minus A over 3 plus D over 3. Rearranging the terms and simplifying, this process is the same as finding the average for days 2 through 4. We get A over 3 minus A over 3, canceling them out, plus B over 3 plus C over 3 plus D over 3, and all of that is equal to B over 3 plus C over 3 plus D over 3, which is equal to the sum of B, C, and D divided by 3. Now let's calculate the simple moving average using the addition and subtraction method. Use the subtraction and addition method to determine the 4-day SMA for the following closing prices. This would mean, to begin with, we would use the first 4. So 121 plus 122 plus 120 plus 119 divided by 4, and this will give us 120.50. Now, if we want to subtract that 121, we're subtracting 121 over 4 because we're actually subtracting it from this average. We're also going to add in the new 124, which is 124 over 4 because we're adding it in as an average. And when we do this, we're going to get 121.25. So our first one was 120.5. Our second one is 121.25. Then we will subtract 122 over 4, and we will add 128 over 4. This is going to give us 122.75. From there, we subtract 120 over 4, and we add 128 over 4 to give us 124.25. So the simple moving averages are 120.5, 121.25, 122.75, and 124.25. Let's check our understanding. Use the subtraction and addition method to determine the 3-day SMA for the closing prices. We start by doing 28 plus 31 plus 37 and dividing that by 3. This is going to give us 32. Now, to get the next one, what we're going to do is we're going to subtract 28 over 3, and we are going to add 38 over 3. This is going to give us 35.33. Now we will subtract 31 over 3 and add 35 over 3. And this is going to give us 36.66. Let's extend our understanding. In example 2, what would the 8th trading day's closing price have to be so that the next moving average remains the same? In order that the next cycle of 4 consecutive days has the same SMA as the last cycle, the number subtracted, the 4th day's price, and the number added, the 8th day's price, need to be the same. Simple moving averages are more informative when they are determined over a longer period of time. Often, financial websites and newspapers report long moving average time intervals. These calculations are time-consuming if done by hand or even using a calculator. However, if you're using a spreadsheet, you can get results easily and quickly. The spreadsheet shown lists the closing prices of 30 consecutive days of trading for a particular stock. The 10-day moving averages are calculated in column C and begin on day 10. Cell C11 equals the average of the closing prices on day 1 through 10. Spreadsheets have a sum function, which is used to calculate the sum of amounts in a group of cells. The format for using the sum function varies depending on the spreadsheet software that you're using. The format used here is equals sum starting cell colon ending cell. The formula in cell C11 that yields the correct average is equals sum open parenthesis B2 colon B11 close parenthesis divide 10. The cells have been formatted to show all decimals rounded to 2 places. The formula in cell C12 is equals sum open parenthesis B3 colon B12 close parenthesis divide 10. Notice that the starting and ending cells in the formula have each shifted down 1 cell. Rather than typing this formula repeatedly and changing cell names used, more spreadsheets have fill command that recognize the pattern. To use this command in a spreadsheet, select the cell with the formula you want to copy. Then choose the appropriate fill command and drag through the cells that you want to fill with the formula. Most spreadsheets allow the user to fill up, fill down, fill left, or fill right. In this case, you will fill down. The formula is placed in each selected cell, and the cell names automatically adjust for each row. Now, let's calculate simple moving averages using a spreadsheet. Use the spreadsheet to calculate the 5-day SMA of the closing prices for these 10 consecutive trading days. List the days in column A, the closing prices in column B, and calculate the moving average in column C. Moving averages lag behind the closing prices, so in cell C6, calculate the average closing price for April 28, 29, 30, May 1, and 2. The formula is equals sum open parenthesis B2 colon B6 close parenthesis divide 5. Next, highlight the cells C6 through C11 and apply the fill down command to have the 5-day moving averages appear in the appropriate cells as shown. Let's extend our understanding. In column D to example 3 in the spreadsheet, calculate the 3-day SMA. In what cell do you start and what formula are you going to use? We're going to start in cell D4, and the formula that we're going to use is going to be equals sum B2 colon B5 close parenthesis divide 3. Sometimes investors construct stock charts that depict moving averages for 2 different intervals. The graph with shorter time interval is known as a fast-moving average, and the graph with a longer time interval is known as a slow-moving average. As changes in closing prices occur on a day-to-day basis, the fast-moving average will reflect those changes quicker than the slow-moving average. A crossover occurs when one time interval moving average graph overtakes another. Crossovers signal that a stock trend's reversal might be near. Some say that an investor should consider buying when the fast-moving average graph overtakes or rises above the slow-moving average graph. Likewise, an investor might consider selling when the fast-moving average graph crosses below the slow-moving average graph. The graph shows the closing price for 29 consecutive trading days. It also charts the 7-day and 21-day simple moving averages. What signal might the graph give an investor? The crossover occurs on the 27th day. The fast-moving average graph rises above the slow-moving average graph, giving a signal to consider buying the stock. Let's check our understanding of this. Suppose that on the 35th trading day, the 21-day SMA graph rises above the 7-day graph. What might this indicate? It might be saying to sell. The slow-moving average has overtaken the fast-moving average graph, indicating a reversal in the trend. The buyer might consider selling the stock. As you've seen in previous lessons, regression analysis can be used to see if there is a correlation between 2 sets of data. Financial analysis uses a variety of regression techniques to look for trends in stock prices. Many of the methods apply complicated formulas and procedures to produce graphs that allow analysts to make a data-driven prediction on where the stock may be headed. They might then decide to buy or sell a stock based on the information from the regression lines and curves. In the first 4 examples, we found simple moving averages that allowed you to smooth the data in order to get a clear picture of trends. In the examples that are going to follow, you'll do the same using statistical and graphing features of a calculator, software, or spreadsheet. Examine the 36 consecutive trading day closing prices for ZZB. The chart covers the trading days from January 6 to February 26. Construct a scatter plot and find the regression lines and the correlation coefficient. Use the equations to predict the closing price on the 37th day of ZZB. Using a graphing calculator, graphing software, or online graphing website, or even a spreadsheet, you can generate the following scatter plot, starting with January 6 as the day 1 and January 7 as day 2, and so on. Use the ordered pair 1, 34, 2, 33.51, etc. in that form. Day number, closing price to construct a scatter plot. The regression line is determined using the ordered pair in a chart. This line has a positive slope, indicating an increasing price trend. The correlation coefficient is strong at 0.94. Use the linear regression equation to make a prediction for the closing price on the 37th day. We're going to substitute x is equal to 37 into the equation. Y is equal to 0.1123x plus 33.583 and round to the nearest penny. So we just simply get to say that equation. Y is equal to 0.1123 times 37 plus 33.583. And this is going to give us that y is equal to 37.74. The predicted closing price for the 37th trading day is $37.74. Let's check our understanding of this. What closing price might be predicted for the 38th trading day? Well, we're simply going to use that formula, y is equal to 0.1123 times 38 plus 33.583. And this is going to give us y is equal to 37.85. Use the data from example 5. As we have seen previously, sometimes you can get a better regression function by using polynomials. The quadratic regression curve is the equation y is equal to negative 0.0026 x squared plus 0.208 x plus 32.976. The cubic regression curve is y is equal to negative 0.00014 x cubed plus 0.0051 x squared plus 0.09212 x plus 33.358. The quadratic regression curve and equation is y is equal to negative 0.000028 x to the fourth minus 0.0022 x cubed plus 0.0547 x squared minus 0.3289x plus 34.223. Notice the similarities and difference between and among the linear and quadratic, cubic, and quadratic equation graphs. The linear shows a strict increase trend, although the quadratic is increasing. It appears to be tapering off in the last few trading days. The cubic equation increases at first, but then turns downward. Finally, the quadratic shows more of the hills and valleys in the trading prices, but appears to be indicating a continued increase in the trading prices as the days go on. Keep in mind that the coefficients and constants in the equations have been rounded. The predicted closing prices using the 4 regression equations are as follows. The linear would be 37.74, where the quadratic would be 36.66, and the quadratic would be equal to 37.98. As you can see, using regression analysis as a stock price prediction tool is not an exact science. That is why analysts use multiple prediction methods before making large and expensive trades. Let's check our understanding of this. In the cubic and quadratic equations, the rounding of the coefficients of the terms with the highest degree has a significant impact on the predicted value. Calculate the predicted closing price on the 37th day had the coefficient of the highest degree cubic term been negative 0.001 and the highest degree quadratic term been 0.00002. Why do you think there's a difference? Now, when it comes to the cubic term, by changing that, which means really dropping off that little 4, what we get is that would be equal to $36.68. And when we drop off in the quadratic the 8 that was there, we get $22.98. In each equation, the first term has the greatest effect, since the x value is being raised to the highest power. Reducing the accuracy of the coefficient of the first term will have the greatest impact on the answer.